Well, welcome everybody. Thank you for joining us here for a webinar on utilizing your harvest data and really focused on utilizing the Engage app to really bring that harvest data to life. So critically, why are we here? We have really been on this journey on trying to make sure all CropScan users have the best opportunity to maximize the data that they've collected at harvest. So the yield and protein story is one that's now been sort of discussed for the last few years as a really valuable tool, initially for the nitrogen management, but it does go into so many more other steps around reviewing your overall field performance and on into your overall farm management plan, especially linking that through to the variable rate strategies. So thank you for joining us today. And hopefully today just really want to tick off, get a number of questions just really around how do we actually start utilizing this protein data and what are some of the steps towards the interpretation of it? Obviously, we're dealing with growers from so many different rainfall zones, soil types, and overall production systems that, yeah, we see a lot of data come through, but need to work out what strategy is going to fit your system best. And it's not a overnight journey either. As many of you might have seen, some of this journey over 3-5 years on chipping away at utilizing your data, acting on it, and going in a positive journey for improving that nitrogen strategy initially, but then what is it telling us about other nutrients and how do we work towards evening up the field? Because we have an even protein map, it means we've maximized that fertilizer availability or nutrient availability relative to the available water. So if we constantly think about that as how protein fits into our overall data stack, we can see how that protein layer has been a bit of a missing link and where it all fits in. So on to today's agenda, just really want to do a bit of a deeper dive into that protein to prescription concept and what other growers are doing as well. The use of the analytics functions, so that's really what we've tried to bring to life in the app, is some of the main tools that growers have been utilizing historically with looking at this data. How can we bring that to all users? That data interpretation and supporting that nutrient decisions, utilizing the data to then supporting soil testing strategy, which is a key piece of the learning puzzle as growers are getting their heads and overall management around how does this layer fit in, the prescription creation, and then the exporting of that prescription. There are other training videos that are available on our YouTube channel and through our website that for individual steps of this, and keep an eye out for updated videos that are coming through as well. But this is really a forum for us to, one, just sort of run through some of these steps, and then also please feel free to chime in with any comments or raise your hand and we can address any questions here sort of face-to-face virtually is sometimes a good forum for if you're happy to share some of your questions, we can discuss them here and others can support some of that decision making. So we do have some new functions coming into the Engage app and the overall cloud portal as well. So we've got now individual map analytics processing, which we'll run through today. We are now supporting more file formats and simplifying that file upload in the CropScan Ag Cloud portal. So if you haven't done any yield importing yet, there are some other videos available for that yield import, and we'll also, as we release these updates later this week, that will get simpler to do some of that management. So please reach out with any other questions around some of that yield importing and yield and AB lines, but there are some resources available for you to do some further research yourselves, and then we can fill the gaps from there. So working through that ISO XML yield data import, also with the CN1s, so we've had a lot of growers that, it's that age-old story of a lot of data quite often still packed away in some of these CN1 files, so multiple years, but they might have only had the protein monitor for the last year or two. So we can just do more of a select import on the last 2 years, which just streamlines some of that data processing. And also for John Deere users, we were previously doing individual shape files per field, but now we're working on that overall batch shape file yield import, and then we can unpack it from there. So a few neat functions just to streamline that processing of that yield data. So as we go into this protein to prescription journey, like where do we see the opportunity, and how are growers around the country utilizing some of this data to sort of take the next steps on their nutrition plan? And it really does wind back to this closing the yield gap opportunity. So when we look at what the main drivers are for closing the yield gap, one of the biggest limiting factors nationwide is the nitrogen supply to the crop at the critical times, which is causing, I guess, one of these elements to the yield gap, along with obviously the moisture component. So how do we make sure that whenever we're managing a field, how do we take the steps towards starting to minimize the gaps where under fertilization may be occurring? And when we look at what that yield gap can be, and we see on the scale here on the left-hand side, it's sort of ranging from that 1 to 3 tons around the country. And quite often when we talk with growers, it's like, how can I be leaving that much there on the table? And when we look at, obviously, fields are getting larger, quite often we default to thinking it's the whole field that's got this opportunity to increase the yield, and we've got this massive yield gap across the field. What we see is there's really these hot spots in the field, which the protein layer can really highlight. So we'll go through today on how we can use protein as that indicator for where some of these nutrition opportunities are sitting in the field that we can quickly address, which doesn't mean it's necessarily going to fix that field. It'll just be, it's like the old leaky bucket theory, where if we address the most limiting factor, which quite often is nitrogen, it then highlights where the opportunities are for the next nutrients. Might be phosphorus, sulfur, potassium, and alike. So we then work through triaging some of those nutrients, but this is really the first port of call. So as we step through it, the basics of, call it agronomy 101, is this working through this nitrogen response curve. So that curve that's going up the chart here is the amount of nitrogen applied. And as you increase the applied nitrogen, we'll see an increase in yield and increase in protein. So this becomes the foundation of where we need to look further. So when we analyze a field, we want to be seeing what sort of spread of protein is in a field. Are you ranging from 8 to 13%? Are you 8 to 10%? How wide is that variation across the field? And essentially, the wider the variation, the more opportunity there is. So what we want to be then looking at is having the discussion with yourself or the agronomist and saying, well, where is it sitting as far as what our target fertilizer rate is based on our target protein? So different areas will have different target proteins. So ranging from sort of that 11 and a half, which is considered as the sweet spot here in Australia as a target protein generally. But you go to different areas depending on what a lot of their finishing conditions, especially, they might be sitting around the 10.5, 10.8, and others sitting up in the 12. So depending on, have that discussion with your agronomist and say, well, when we are doing our normal nitrogen calculations, what are we doing? We're working on a 4-ton crop with 11% protein, or are we chasing 10.5? Or what is your own sweet spot? When you start analyzing your own protein data too, it does actually help you analyze what should your target be, because we go to different areas and different soil types. You're like, you know what? There is actually more opportunity than quite often the kind of standard prescription has been, I guess, giving some of these soils the opportunity of. So as we look in the areas where we've got low protein, so down in this red area of the graph, if we see low protein in a field, we can quite easily see that there would have been a yield response as well with an increase in nitrogen. So that's just that standard yield protein response. So as we increase that nitrogen, we should see a yield increase, but also deliver that protein increase. All this then does come down to the timing of the nitrogen application. And I guess one of the biggest interpretations initially of this data is when growers will be looking at this information and think, okay, think kind of too much on the protein side of it, and just look at a later season application of nitrogen to look to vary. And all that will do is definitely drive that nitrogen into the protein pool where what we're finding is the earlier we're going is that it is helping the plants set up that increased yield. So think about the timings. When are you going out to either apply nitrogen down the tube at planting or looking at your follow-up applications? Depending on your rainfall, will depend on how much they get varied. So we'll see some areas that have now, after analysing their data, will have greater appetite to now put some more fertiliser down the tube. So running a second line with urea or UAN going separately, but it might only be for certain areas of the field. And then in other areas, it might help justify why they're doing an extra application, or each of the maps that each of the times they're applying fertilizer will actually be applied on a variable rate strategy rather than doing blanket for the first 1 or 2 applications and only variable rating the last one. So something to think about within your own system there is saying, think about where that timing is and what that opportunity is. So where do we start to work out what sort of nitrogen application rates would it take to start moving up the curve? And this is always sort of that debate that comes into it around where it's all sitting as how do we navigate what this data means. So what we want to be looking at these, what is the amount of area that's sitting in the low protein zone, how much area is in this target zone before this graph plateaus out, and then how much of the area is high protein, because generally they've had an abundance of nitrogen available relative to their available moisture. And these zones might show up as being soil type related, or might be a frost zone, whatever. There might be something that's causing that high protein, but generally when we see that high protein, it's telling us there's been excess nitrogen relative to the available moisture. So on the I guess in the different zones, it's going to depend how steep this curve is based on your rainfall and your soil type. So how much of a yield protein response we get, but hearing from different growers, when they're getting it right, they're quite often sitting in that 300 to 600 kilos of yield response per percentage point. They are below their sweet spot. So that gives us some numbers to start working from. And where does it all strip back to? So when we look at the basics of the nitrogen removal, is what we're calculating with the crop scan is a total nitrogen content based on the near infrared measurement, which is then calculated into a protein measurement. So the nitrogen makes up 17.5% of the grain, of the protein in the grain, and then sulfur is 3.5%. So we can then work out that calculation for protein. By the same token, we can reverse calculate that to get a nitrogen removal. So this is a really simple matrix, just working on that 17.5% content in that protein of that as we go up the protein grades 8, 9, 10, 11, 12 across the top, and the yield down the left-hand column. We can just do a simple matrix of what is the raw nutrient removal when we're varying what the protein and yield is. And this is the critical piece where we start stripping it back on what the fundamentals are when we start working out what should we be varying that application. So you can see at a 1 ton area, as we're just going up, we've got around the 2 units of nitrogen roughly per percentage point as we go up per ton. So that gives us the starting point of saying, okay, well, a couple of units of nitrogen, that's called best part of 5 kilos of urea, working on 46, call it 50%. So that starts us on that journey on saying, okay, we need an extra 5 kilos there. Then if we're chasing a yield response as well, we'll then be stepping up that overall removal. Quite often growers are sitting on a sort of a rule of thumb removal of around that 20, 21 units of nitrogen removed per ton of grain, which, as you can see, depending on what that protein percentage is, it does vary a lot more than that. And this is sort of the steps of where we can highlight where some of that slip is in the system, where when we just do back of the envelope calculations and saying, yep, 20 units per ton removed, we'll double it, and basing on to get to the urea calcs, and that's what it can get there is quite often a lot of slop, call it, in the system. So a bit of wriggle room. So this is how we can start using this matrix to tighten that up. So for example, if we had two areas in a field, and for the argument's sake, we've put out 100 kilos of nitrogen on this site, we might have a 2-ton area going 13%, has only directly removed 45.5 kilos of nitrogen, where in the 4-ton area with a lower protein at 10% might have removed 70 kilos of nitrogen. So when you look at that, call it from an efficiency base, this area of the 4-ton is running at a 70% efficiency versus 45% efficiency in that lower protein, lower yielding zone, or the higher protein. So this is where we can really start getting the confidence in saying how much should we be varying our rates. And this is what really helps sort of strip it back and get the growers to understand where they might go on changing their rates per percentage point, utilizing that protein layer. So really simple tool just to help hopefully put it into context around what is that removal versus how we might look to apply and target that correct nitrogen rate for you. So the fundamental element in this is still, I guess, that message around is we're not chasing protein, we're using protein as an indicator. And from that last matrix, hope you can see when you start looking at that in sort of reverse engineering what the data is telling us, you can see how that nitrogen is having completely different efficiencies. So unless you're in a zone, a rainfall zone that's having a significant leaching event, and I know we've had a lot of rainfall over different parts of the countries, but this is where we need to be tracking how much moisture are we actually losing out of the bottom of the bucket through the profile. If not, what nitrogen has been applied, if it hasn't been removed, it's still sitting within that soil profile. So that gives us confidence on a year-on-year approach to say, actually, we do have confidence to back off some of that nutrition there. Because quite often we think, I can't wind back 30, 40 kilos in that area. I know that the field needs it. But when we can see that we've got that carryover, that legacy nitrogen sitting in maybe 15% of these fields, that's where the opportunity sits. So as we go through this, we're really utilizing that protein as that field performance indicator. And really, how does it link into this overall strategy of saying how much moisture have we got? So that soil moisture, linking that to that soil fertility, and then how that loops through to the crop management. As soon as we just don't want to be looking at it in an individual silo, we want to be joining the dots on this. And that's what helps at advancing us forward. Because no, we can't predict how much rain there's going to be, but we want to make sure if we have those more marginal years, we shouldn't be seeing any low protein zones. And it is amazing when you start reviewing the data, a lot of areas there'll be pockets in fields that even on a marginal year will still be running low protein. And that is really a huge opportunity. So when we talk on nitrogen strategies, it's all around the nitrogen budgeting. And obviously we're doing a lot of planning at the start of the year. And I guess that's where a strategy sits. And then we can really backfill that with the tactics based on what the season is holding, based on the amount of rainfall. But really, as we were sort of talking on before, if we have this, if we're assessing how much moisture we're losing through the profile and doing a bit of a nitrogen balance year on year, we can have confidence in some of these zones that are retaining that nitrogen. So it is worth having the discussion with your agronomist and getting on board to say, how can we best utilize this data? So generally, most growers will be working on, say, an end demand kind of nitrogen strategy. So we'll be looking at, like, what's my target yield? What's my protein target? And then work on that removal factor. Is it 20 kilos per ton? And use that as the foundation, which is totally fine, but does, as we saw on that matrix, does leave opportunities for a bit of wriggle room in that nitrogen sort of efficiency. There's a bit more discussion and research happening in the nitrogen banking. So it's really looking at more of a longer term strategy and saying, right, how can we keep maintaining sort of almost no matter what the season brings, let's work on what a season average should be and back ourselves into supplying that level of nitrogen, which for the growers on that end banking type approach and running kind of, call it a higher steady state level of nitrogen in their soils, they're ready to capture those higher rainfall years when it is harder to sometimes keep that nitrogen rate up to the rate at which the plants are growing. And that's where the opportunity is on that rolling sort of 5-year approach to nitrogen, is where some of the growers are getting more interest in their end banking. So a number of you might have end banking trials in your areas. It's worth finding out more around what some of those rates are and how that's all working in some of the, I think they're on a sort of year 2 of some of those trials, 2 to 3, and a lot of work being done out of the Birchip Propping Group on this nitrogen banking strategy. So utilizing this data is definitely helping us point in the right direction for best managing that end banking strategy, so we're not over fertilizing areas that really don't need it. So now, as we go through to the protein to prescription, I guess, application, we want to, we want to be simply using the harvest data we've got. So yield is still a really valuable piece of the puzzle, and we want to make sure we're collecting good yield data. So, because that really gives us the quantity of that bulk nitrogen removal. The protein then gives us the really refining on where it sort of essentially is that fertilizer scorecard on saying, actually, how much availability of that nutrition, was it adequate or deficient in some of these areas. And so we'll get that yield and protein, and we used to do it manually for a lot of our growers and run all the program to be able to get these yield protein overlays. But if we get the yield, look at that individually, get the protein, and then we'll do what we call those field performance maps, where we'll run this yield protein overlay to generate these 4 zones, or this correlation quadrant, essentially, of what the data is telling us. So in these 4 zones really tells us 4 different areas of performance and also future potential. So yes, it is a snapshot from that year, but year on year, you can then interrogate these maps to say, okay, these, whether it's a wet year or a dry year, some of these areas are still falling short and some of them are advancing. So what does some of these colors mean when we do this correlation quadrant? Is basically we've got it into 4 zones. Of being the green zone being our target. So target yield, target protein, and we can set that, and we'll run through in the Engage app how we can run this calculation. So that's our what we've essentially fertilized for. We've then got the high yield, low protein. So that's the yellow zone. And when we see yellow, think nitrogen limited, think of a yellowing crop, but that nitrogen limited zone could have essentially been, would have a yield increase if there was more available nitrogen to that. So we want that yellow zone to be in future all part of that green zone. And with that, we'll bring some of that yield change as well. We'll then have the low yield, high protein. So if that's the blue zone. So when you think blue, or when you see blue, think moisture limited. And that's where it could be soil type related. Quite often will show up as a frost zone as well, but definitely really good at showing where we've got the shallower soils or subsoil constraints and something limiting in that zone. Then we've got the interesting zone, which is the low yield, low protein, which is the red zone. Quite often, a lot of these red zones are sitting on the borderline of the yellow zone. So they will actually respond to nitrogen. Other times they need a bit more investigation, and that we've quite often seen that there might be a co-limitation there, such as phosphorus or potassium or sulfur, something else happening in those zones. So just by doing this simple field performance summary, it really helps streamline sort of that thought process on, rather than trying to sit maps side by side and try to work out what's going on. This really helps us hone in on saying where are some of the opportunities of where we should be varying it. And what we'll see is the blue zone, generally, when we start talking about our soil testing strategy, is even just picking out a few of these fields where you've done this correlation work and look at that field performance and say, well, let's do a test in the yellow zone, because there's a fair chance what we're seeing generally across the board is where you've got the lower protein will have lower residual nitrogen left in the soil when you go and do a deep end test, where the blue zone especially is, because it's been a lower yield area and then indicated by that higher protein, we really haven't had the bulk removal of nitrogen from that area. So that's where we'll often have 30 plus kilos of nitrogen in a deep end test showing up in that blue zone relative to the yellow zone. So that, again, correlates back to that matrix we were talking about, but really does help build confidence in the strategy around this. I'm saying, you know what, that blue zone keeps on having, like, delivering a ton less yield, and that nitrogen hasn't leached out, it's staying there. Let's have the confidence to back off in that zone and allocate some of that fertilizer spend that was going onto that blue zone into that yellow zone and help push that zone forward. So that's really the fundamentals of how we're stepping through some of this data management and interpretation. So we want to make sure as we go down, as we start stepping towards utilizing the Engage app, I just wanted to rehash to make sure that you did get the most out of the system as you are collecting data. And if you haven't got your whole system connected, going from the in-cab display connected to the CropScan Ag Cloud to the to your machinery portal and then the Engage app, let us know, or there are some other training videos around getting this connection to all occur, because this really does streamline this whole data flow to work through. One, brings all your boundaries in, keeps all the naming conventions the same, and keeps it standardized around your main digital farm. And then, so if you haven't got your data off your in-cab display, either make sure your CropScan Ag Cloud account is logged in on your in-cab display, and then either pair it to your phone or internet to send that data across, or you can do a export onto a USB and then import to the CropScan Ag Cloud manually. And there are other reference videos for that. When you are looking at the data, just so we're all across it, all of that data that you've been recording, if you weren't connected to the internet or anything when you were, cellular when you were harvesting, all those files are still stored on that tablet. They're all in CSV. And if you are referencing going back either to the CropScan Ag portal, you'll see in there that all your fields in the protein folder are named in the same way. It's the grower, farm, field, serial number of your machine, and the number of the year. And then you'll want the files that end in -map, so the map files. So rather than all of the larger files that are sitting in there, some of them are full spectral files, we want, for the mapping side of things, just to focus on these. So if you do have a look around, they're the files that we actually do require. But like I say, there are other videos to help reference that.
Thank you for joining, and you can find more information and training videos on our website at www.cropscanag.com.